anybody is watching. Okay. So, is this big enough? Cool. So yeah, so we have a create greetings function that takes in an argument, message, and name, and it returns the string message plus comma space plus name and an exclamation point. And we console log this out, it should say hello Angie. Pretty straightforward. We've all seen this syntax before. So let's hit save. We go to our handy terminal. We'll execute this file. Boom, hello Angie. Nothing too crazy over there. Now we're going to introduce a new way of writing that very same function, except we're going to include an arrow. And you guys might have recognized this arrow from the previous class and weren't too sure what exactly that meant. It's a short form of creating functions. So in this particular syntax, we're still taking two arguments, message, and name, except we get to avoid having to write out the function, the entire word of function, include an arrow, so that JavaScript understands that this is actually a function that is being created over here, and we're assigning it to create greetings. So I'm going to comment this out. We're going to execute this file. Whoops. And then we see hello Angie. Nothing too crazy going on here. It's just two different ways to do the exact same thing, except for some developers it's faster to avoid having to write out the entire word of function, and you can use an arrow instead. At least initially. There are some implications with using an arrow. We'll get into that in a second. But any questions at least on just basic syntax replacement? All right. And you guys should have all the exercises available to you on the Slack channel. Feel free to download that. Definitely follow along. It'll be very useful for you to do this along with me as well, so you can really grasp what's going on. Now, another way of creating this function is like so. And you can see in this particular example, we're also creating the create greetings. Sorry, 1 second. I can hear you, but I can't see the live stream. That is strange. 1 second, guys. Let me just make sure this live stream is working. Let me confirm something. That should be that. Alright, give me 2 seconds. Let me figure this out. One more time.
Yeah, so you don't have to switch back and forth.
Okay, I think we should be back in business.
You don't have to do it.
All right. Okay, now that we have the stream working again, lost my train of thought. Okay, so we're creating the create greetings function once again, except instead of writing it out in this long form syntax, you can do it all in one line if you feel that's easier to read for you. And then in the same vein, we're taking two arguments, message and name, and then using the arrow syntax, and you'll notice that we're not including the blocks. What's up? Oh, whoops. All right. All right, now we're back in business. All right, so yeah, we're turning this multi-line syntax into a single line. We're removing the blocks for the scope, but the functionality remains the same. Some people think this one line is more readable than the other. It's subjective. So just know that you have, if you should still feel the need, you have multiple ways to do the exact same thing, which is create a function. And just to confirm, I'm going to console log this out to show you that the functionality remains the same. And you can see it's still hello Angie. Next, we are going to, if the arrow function only has one parameter, you can even omit the parentheses if you think it's too verbose. So then you can then say, for this particular function, we're creating a function that takes in an argument called greeting, and it just console logs out whatever greeting is referenced to. So for our example, let's see, let me leave this available. We have a function that we created earlier called createGreeting that takes in a message and a name. We now have a second function called greeting that just takes in a parameter and console logs it out. So now we're going to assign the return value of createGreeting, which we saw earlier in the function in the terminal to be hello Angie. That gets associated with this variable called greeting, and then it just console logs it out. So we remove this console log. We know it console logs it out because we can execute this second function called greet, and that just console logs out whatever is the return value of this parameter, which we know happens to be this variable. So if I execute this function now, we still see hello Angie. This example is a little bit more convoluted. You might it would benefit you for at least for readability purposes to kind of use the more verbose syntax above, like even potentially this one, the second one versus the first one. But I hope you get the gist of what they're trying to explain to you. That if you want to write in short form, this is how you would do so. And there's a couple shortcuts to kind of save you time and hassle from the keyboard. So questions at least on this. The what?
ES5 versus ES6.
Oh, that's just the name of the standard that they have for JavaScript syntax. It was ES5 and now 6 is the latest version. Cool. All right, I am going to also send you a quick blog that kind of gets into a few of the other major differences between EX5 and 6 that you can read in your own time. The next file we'll look at is context. This is where I kind of get into some of the nuances behind using an arrow. Besides just short form syntax, it changes the way that this object works in relation to functions and objects. So, let's see. Let me comment this out. We'll start with a very simple case. We have a person object that has a key name, Hodor, has a key say something that gets assigned to a function. This function, you'll notice, uses this. This name is thinking. So at least from reading this, what are we expecting to see when we execute this function and it hits this console log? Okay, and why is that? Because what is this referring to? Well, this refers to the object. The name is the key within the object. So this would be this object person, and we're accessing the attribute name. Then we're going to set a timeout. And within this timeout, we were assigning another anonymous function. And this console logs out this.name exclamation point. So let's execute that and see what happens. Context. So the first console log did exactly what we expected it to see, but of course the second one is undefined. You guys might remember seeing this when we were doing front-end development on the browser side, that this no longer becomes associated with the object anymore. This is, well, if you were in the browser, it would be assigned to the window, the global scope. But in this particular case, the global scope in Node, so to speak, is just an empty object. So I'm going to console log this in the beginning. And actually, no, I spoke incorrectly. This would pertain to the timeout object. Let's console log this, just so that you guys can see what's going on. All right, node 02. All right, so that very first console log is going to be empty because there's nothing in the global scope right now in Node. is going to hit that second console log, which would be Hodor is thinking. That makes sense because this refers to the object. Now within a function within a function, this now no longer pertains to person anymore. It doesn't become associated with the global scope because that doesn't exist. Window does not exist in Node.js because we're on the back end. So this would relate to the timeout object, as you can see over here. That's why it prints out timeout. Now, looking at the timeout object, you'll notice that it has no attribute called name. This is important. That's why it's undefined. Keep in mind, you might accidentally use an object that does have name assigned to it, and then you'll get funny behavior. Not the behavior that you want, because we're expecting Hodor to be there, but if timeout had an attribute called name and it, I don't know, blew up your computer, then, that's not what you want to happen. So because of that, Arrow got, the only way you would fix this, like to make sure that this related to the object, which would be person that you want, you'd have to use fancy functions like bind in native JavaScript. But with ES6, Arrow helps handle that binding functionality for you and enforces that this object, if you use it within this context, would pertain to the object person. And we'll see that in the next example. So let me comment this out. This. Now in the second example, whoops, too much. We have the object person. It has an attribute Hodor, name Hodor. And then in the say something function, it's still associated with a function, and we're still console logging out Hodor is thinking, except timeout now has the arrow syntax for the function. Even though we know it's an anonymous function, it takes no parameters except we're using arrow. And this will enforce the fact that this remains binded to the object person. So when I print this out, I clear the screen, you'll see that it's Hodor exclamation point because this syntax enforces the bind functionality to this and ensures that this always relates to the object. So it kind of saves you time and hassle trying to figure out a solution for how would I get this in the first example to stay binded to the person object. Developers were complaining about this for a very long time, and that's why it was introduced in ES6. It's going to save a lot of time and hassle. Rather not get into bind right now, but I can send you some resources about it. Cool. All right. Next. Okay, so in this one, you'll see we have an object called dog. It has a couple attributes, name, sound, and some functions. Now, generally you want to avoid using arrow functions as object methods. So you'll remember in the previous example, we're using the old way of actually defining the special keyword function and associating that with a key. We don't want to do that with arrow functions because then you get some funny behavior with this. So let's see what happens when we execute this. Clear. You'll see that it tried to execute dog makes sound, and then we got a undefined, and then in the next one we also get another undefined because it keeps trying to point to an object which is not associated with this object over here. So let me change this from sound to this and show you what it actually tries to print out. And it's the empty scope. You see, you got associated with the empty object that Node has defined for this when it first boots up, which is not the behavior that we expect. So just be aware that when you are defining functions for objects, you have to use the old ES5 syntax and not to use the new ES6 syntax, or you'll see funny behavior. So just kind of like a heads up. That's what this one is kind of telling you. So questions on that? All right. So just to kind of reinforce this a little bit, we're going to move on to an exercise, exercise 17. You guys will play around with the unsolved version, and in this exercise, let me slack out the instructions. All right. You're pretty much just going to take a look at this code and determine from the examples that you see in exercise 16 which of these functions would benefit from using an arrow, or well, they don't even need to actually benefit. Which ones can you just replace with the new syntax and not break functionality? So first thing you want to do is to confirm the functionality happening in the beginning. So maybe comment out all the other exercises 2 through 3 and start with 1 and just execute that. Make sure you understand what it's doing in the funny case function, and then replace that old syntax with a new syntax and ensure that you didn't break anything. We'll do this for the next 10 minutes. And feel free to work with a partner if you feel that's easier for you to understand things. Okay, let's gonna walk through this as a class. Let's see. Let me open up this solved section and then the unsolved. Put them side by side. Cool. So we will have the unsolved on the left side and the solved on the right side. The first case is straightforward. We know it takes a parameter string, only one parameter, so we can just completely remove using the name function. And then actually, because it's only one parameter, we can also remove the parentheses. So it just becomes string, arrow, and then the rest of the code remains the same. In the second example, because we do have two arguments, we can remove function, but we have to maintain the parentheses. So it would be r and then cb, arrow, and the rest of the code remains the same. Actually, no, that's a lie. On line 28, there's another function doubled that maps the numbers, and in that it has a function that takes a single argument called element, and that can also be replaced with a single line with an arrow to element multiplied by 2. Who was, out of this class, who was able to get line 28? Raise your hand. Okay, cool. Yeah, this takes a while to get used to, the new syntax, at least trying to understand the nuances behind them, when to use which one, what shortcuts to use. But in time, you might find which syntax works best for you, and then use that. So for me, I still prefer to use parentheses. It kind of helps signal that it's an argument, but to each their own. Then for line for number 3, you have a function takes in 2 arguments, and that's still the same case where we'll remain using parentheses to denote that it's taking 2 arguments. We'll include the arrow, remove the function, and then on line 49, even number turns into a single argument current element. Let me stretch this out, and then the actual function logic remains the same. So this is also very similar to number 2. The fourth one might have tripped you up a little bit because it's an object. And remember, we said in the previous exercise in the third file that when it comes to objects, we don't want to use arrow notation because we'll lose the context for this. So even though we have multiple functions being defined for each individual key, you'll notice in the solution these remain the same because we actually want to use the object being defined within Netflix queue. So the object Netflix queue has a key called Q, and that queue is being reused in each of the individual functions. So all of that remains the same without any arrow syntax enhancements. So any questions on why that's the case for option number 4? All right. So then moving on, let's exit this. We're going to talk a little bit about some more new syntax provided by ES6. We're going to be introduced to something called let, and also how it gets used within your code. Did I comment these out before? So we're already very familiar with var. We know var is being used to assign an object to a variable. So let's say this is a test variable. We can be assigned to an object. Let works in the very same way. You would do let test equals object, and now this object is assigned to a variable called test. Except this special keyword, an easy way to understand this is every var can be replaced with a let. And when that happens, you get to take advantage of some of the new features that let provides, which is scoping. So let me show you a simple example so I can really enforce what's going on. I'm going to comment all of this stuff out. We're going to focus on this very first loop. And in this loop, it's going to iterate 5 times and it's going to console log out all the numbers. Let's execute this function. This is number 18. Node index. All right. And actually, I'm going to comment this out as well. you'll see that just for the loop itself, it prints out 0 through 4, and it ends the loop. That's expected behavior because I is less than 5 is not I is less than or equal to 5. So it's not going to print out 5. The problem with var is that var remains within the scope of execution longer than it needs to be. So when we console log out I, which is variable I, you'll notice that it's already been incremented at the end of this loop initiation. So even if I was to comment this out, you wouldn't expect to still be able to have access to I. So it leads to like funny behavior. So let was introduced to kind of resolve that type of behavior. So if I just replace var with let, and I try to execute this function, you'll see that we get an error. I does not exist because we don't want it to exist. Once that loop has finished execution, that's it. We don't want to have access to any of those random variables because what if you want to use I later on and now you have some weird behavior in the second loop. I is now 5 and that now starts at 5 and so on and so forth. So let helps you kind of enforce scoping for the different variables that you have in your application code. So just for this very simple loop question, example, do you have any questions on scoping for let? It was kind of introduced to help catch errors earlier because as you'll notice, JavaScript does sometimes do magic on the back end and try and force the code to work, and sometimes that's not behavior that you want. So for example, double equals versus triple equals. All right, so let's go to the next example. In this example, we are assigning x to 42, and then within the loop, we have another variable called let j, and that prints out some numbers. And then x will also print out some numbers, and then when we console log out j, because we're using let, as we saw earlier, j is no longer within the scope of the global scope being defined here. So we'll get an error that j is not defined. Then we can assign j again, and we'll see that it's prints 42. So let's just execute this by ignoring this section first. Clear node index. And you will see, oops, did I save this? All right, yeah, let me get this out too. And feel free to execute this along with me, just so that you can see the behavior going on yourself, and even maybe potentially try use cases in your own time. But you'll see that it prints out all of the iterations within the loop and along with x. Why is it printing out x? Why is that not undefined within that for loop? Anyone want to take a stab at that?
So what's defined before the
So what scope would it be in?
global?
Yeah, it would be in the global scope. So as you guys saw with JavaScript on the browser side, let is X is being assigned to the window, so to speak, the global scope, and that's why you have access to it within this for loop. But you don't have access to J because that is defined within those two blocks. So just kind of want to reinforce that. Then when you print it out, it's going to print out the iterations of the loop along with 42, but when it comes to J, let helps you understand that J is not defined. If you want to define J, you have to do it again. And then it'll print out 42 like you want because now J is part of the global scope. Question? No. So var would if I turn this J into a var instead, let me comment this out, print it out. You'll see that it prints out this 5 when it shouldn't have, because this loop exits out at less than 5. So it should have just printed 4, and then, but you'll notice that instead of just giving us an error saying, oh, J has not been defined in the global scope, if you use var, it has been assigned. And that's not behavior you necessarily want. Yeah, got it? Cool. Does everyone else get it? Because it's important to kind of make sure you get these foundational stuff early. So, because you'll be surprised how often you're debugging a problem due to scoping, because you used a var when you maybe should have used something else, and now you have weird behavior going on. So in the next example, when using loops, any values created inside will exist inside and outside the loop. So same case, we have a var count being defined with 0. It's going to iterate through this loop. It's going to create a variable called tripled. Tripled is going to multiply that count by 3, and then also increment count, and then it's going to try and console log out tripled. Because tripled is a var, let's see what happens. You see, we still have access to tripled, but that's not really correct. It should the longevity or the life of tripled should end the moment this block is done with its work, and so you can move on and reuse that variable name for other purposes. So just kind of showing you examples of where var can sometimes trip you up. And then let's see. In the next case, I'm not even going to execute this. This is pretty straightforward. You have a let, and then the variable quadrupled is assigned to a let. We've already reinforced the fact that the life cycle of quadrupled will end the moment this block has finished execution. So when you try and reference it, you get a reference error. Okay, and then finally, let me console log these ones out. In this example, let's see what we have. If true, then we have a favorite color red, and we're going to console log out favorite color. That's fine. Then when we use let, we're going to define favorite food. That's going to be assigned to the global scope. These are two separate instances. Okay, so first case, we have a variable called favorite color. We know var always assigns everything to the global scope, so when we console log it out, it's red. No big surprise there, because we know that var doesn't respect the blocks, and you'll always have access to it. Now, if we want to do the exact same thing, but we wanted to respect the blocks, we would define favorite food in the global scope, you would assign it to pizza, and then you would console log it out. And just to show you the differences, console.log this first before anything has been assigned, and then console.log this when it has been defined. All right, and you'll see that first of all, there's nothing in there. Then we define favorite food. We assign it to pizza. So once again, this isn't really a global scope, but the variable has been referenced to this object pizza. So it's not going to be assigned technically to this object, but it does exist within the memory of the code execution. So it'll print out pizza still, but this will still remain empty unless you explicitly define some keys to it. Just want to make sure that was reinforced, because that can be quite tricky to understand too. So yeah, any other questions on let? First thing that comes to mind, you can always replace every single var with a let. That only improves your code, because the let will help enforce the different blocks within your code base. That's not actually the case with the next variable that we'll now talk about, which is constant. So with constant, it's also just another way to assign objects to references, to variables. But if you were to take a guess, what would you say constant is used for? Yeah, it's like so even just with the name itself, you could say is a way of defining that a variable needs to remain constant, that you don't want it to change. And there's a new way of doing that, which was defined in ES6. And so let's say we have age is being assigned to the number 25. When we try to execute this, let me cd into that folder location. Oops. And execute it, you'll see that a type error happens, because now we're technically modifying that variable. This variable has been assigned a number 25. This shortcut reference is really age equals age plus 1, and you're changing the reference of that variable, and that's not what we want. If you say something is constant, it needs to remain constant, and so constant was introduced to help catch those type of errors sooner than later. Because before all we had was vars, and vars could be changed to anything, and then you'd have funny behavior going on later on in your code base. So, any questions at least on this simple case before we get into more interesting things? All right. Then in this next one, same thing with the integer, just like the integer with a string, we're assigning the constant name to an empty string, and now we're reassigning name to a string called cherry, but you get a type error saying it's already been assigned. You just can't change it. This type of behavior changes a little bit because when you start talking about like objects and arrays, and then we'll get into that in a little bit. So let me see. We're going to define this object Beatles, and we're going to push George to Beatles. And then we're going to console log it out. Oh, actually, it's already defined there. So clear index. Now, the important thing to understand here is that unlike the previous examples, we're not reassigning the object being associated with Beatles. In fact, we're just modifying the object. So I don't want you guys to get confused that constant means this object can never change. The problem with these other examples is that strings and integers are treated as objects in themselves. So that empty string is an object, that string cherry is a brand new object. So you can't change the reference. But in this example, we're not changing the reference, we're using the same object, we're just modifying it. And that's a very important distinction to understand. So that's why we didn't get any, hey, type error, you're reassigning this object. The object is still, constant is still being associated with this array. We're just updating the array. Questions? Same thing with dictionary. So we're going to create a person dictionary with the name Brianna with a constant. We're going to update the age of Brianna by incrementing it by 1, and then we're going to add a brand new key called favorite movie, and then we're going to update the name to Carla. We're going to print this out. You can see that Carla object has now been updated, which is perfectly fine because the reference to the object remains the same. We're just modifying the object. So keep that in mind. Objects and arrays are exceptions because those objects are modifiable. You can't necessarily modify an integer or a string object because they will create a brand new object, which will now need to be assigned to a new variable. Okay, so now in this next example, let's uncomment this, comment these ones. Okay, so in this example, what are we doing? We are still setting an item, and then we're updating the price to be a brand new price. That works perfectly fine. But in this next one, we're going to get a type error now, because what we're technically doing now is we're no longer modifying the object, we're assigning it to a brand new object. So when I execute this within the code, within my terminal, you're going to get a type error because unlike the previous example where I just updated the object, just modified the object, I am assigning it to a brand new object. So just small examples to continue to reinforce the idea that arrays and dictionaries are modifiable even when you do use const, but for like integers and strings, those are going to try to replace, those are all individual unique objects that try to replace the reference, which is not allowed if you use constant. All right, and in the next example, Ninja Turtles, I'm not going to execute this because this is the same rule which applies. We've assigned Ninja Turtles to an empty array. We're now reassigning Ninja Turtles to a much larger array, but we get a type error because you're not allowed to reassign. What would we do if we want to update this array instead? Push. We would just use this function, do .push, and then apply this this entire array. I don't actually even know if this is correct syntax. Let's see what happens. All right, so we have a constant Ninja Turtle, blah, 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 push, and takes the entire array. Let's see. Oh, well, it didn't blow up. Let's console log that out. Whoops. Ninja Turtles. All right, and then we have an array within an array. So this might not be the behavior you want, but at least now you know that if that's what you wanted, you could do that. All right, so questions of what we've talked about so far when it comes to let and constants in replacement of vars. Because we're going to do a little exercise on exercise 20. You're going to see that crystal game from previous exercises. Sure, that brings back fond memories. All right. And this one, we're pretty much walking through the syntax and just updating the game to use the ES syntax. So building on top of all the previous exercises that we saw before, when we look at the index.js, you're going to see functions being defined. You can replace those with arrows. You might even replace your vars with lets. Maybe some of them might be constants. This is your chance to kind of play around with that and make sure you don't break functionality. So first rule in software development, if you provided some code, execute it. Make sure it does what it's supposed to do. Because the moment you go playing around with things and you break things, it's hard to go back to that original case and understand what's going on. So this kind of reinforces that ES6 is not just for Node.js. It can also be used on the front end with native JavaScript. And we will do this for 10 minutes. Okay. Hey, it looks like there was an error in the index.js for this exercise. I'm going to Slack you out the correct one. Well, here's a question. Who noticed there was an error in the index.js? And nobody said anything. All right, I see what we're going with over here. All right, so yeah, use this one. All right, replace that with the one in the unsolved folder, and that should work. Yes, it's in the general channel. Is that better? That's working for everyone? What do you see? Hmm. All right. I'm just gonna copy and paste it into the general channel. And just copy and paste that into your index.js file. Yeah. Can someone point out who was actually seeing an error? And then just confirm that's right too. Can you see it? Okay. So yeah, so copy and paste what I just put in the Okay, perfect. Cool. All right, so that should work. Just copy and paste that. Be back in business. If you're continuing to see issues, just let me or your TA know. We'll fix you right up. Mm-hmm. So and always remember, you score easy points when you just replace every var with a let. Do that, and functionality should not change. If something changed, then you have bigger problems. With every change, you want to make sure that you didn't break things. Refresh, save your file, refresh the page, ensure there's no errors within your console. Two more minutes and we'll take a look at the solution. Okay, let's take a look at the solution. So, move this to the left. And move this to the right. All right, let's start from the top. The very first function, and just keep in mind, unsolved on the left side, solved on the right side. It creates an anonymous function called makeGuess. Doesn't take any arguments, so let's see if it uses this within the function. I don't see this being reused, so I think this would be safe to say we can just take out the function keyword over here and then leave it and then change it to the arrow syntax. So that one's really straightforward. Another quick win, you'll notice that they changed a lot of the vars to, well, I guess a good way of trying to figure out whether you should be using lets and vars is like replace all the vars with lets and then walk through the functionality and determine what actually needs to be a constant. So the very first variable, which is the root, which is a document query selector to the root object in the HTML DOM tree, we would imagine that we don't want this reference to change. If you're going to be playing around with the DOM tree, safe to say that should be a constant. So they're using constant over here. The same thing with your functions. For the most part, modifiable functions might get you into trouble. So you typically want to make a function a constant so that you know that the behavior of that function is never changing. Then in the very next example, they are defining a function that takes a color argument and then it gets assigned to a variable crystal. And this is doing a whole bunch of stuff with the this object, changing assigning the document.create element div to elements. It has a class name, setting a value, so on and so forth. What they've also done within that function is that they're also using this within a nested function. So I would imagine for this functionality to remain correct, they're going to use the arrow so that this object is binded to the crystal object. And then they left function color alone. Can't remember why that's the case, but we could test it out and see what happens. So let's see. Let's do this. You know, crystal is being defined like so. Let's comment this out. I guess that's fine. Alright, so let's confirm the current functionality as is. And we see that it prints out the object crystal red. It's perfectly fine. Let's update this so that it uses the arrow notation. Refresh the page. And now we can see that we get a type error. Crystal is not a constructor. So in this particular scenario, we're almost using this function to kind of create like a class in JavaScript, and that's why we're using this new keyword to create a crystal object. So crystal is not really a function, so to speak. It's an object. So because of that, you cannot use the new arrow syntax. Because remember, as we said earlier, typically for objects, you want to remain using the old ES6 functionality. So then I will revert that back, and then things should work as expected. Then, let's see. Prototype remains the same. The next thing that changes is within playground. We have a very easy change of replacing the function keyword over here with an empty parentheses and the arrow, and then we're also able to enhance the other functions because we're not making any calls to this object, so we don't really have to worry about the scoping of this. So we could easily replace the function within sort and for each with the new syntax without having any problematic things occur. So any questions on this exercise? Definitely, this is a good one to go home and just play around with. Play around with different scenarios so that you really get a good understanding of what can change, what shouldn't change, why did this not change, so on and so forth. Next, I guess we get into something more interesting, functional for loops. So, you guys might already be familiar with the for loop for each. It does exactly what it sounds like. It iterates through the array and then prints out each object to console log. They're using the new ES6 syntax so that you're aware that for the movie patrons, we're passing in a function that for each element is going to be assigned to patron or patron? Patron? Patron. That's how it's pronounced. All right. You guys, come on now. Patron. All right, so it's assigning each patron object to the variable patron and then console logging it out. All right. You know, yeah, I could definitely do it with a drink. So let's execute this. Let's get out to exercise 21. Let's execute that index, and we see it just iterates through each of the elements in the array and then prints out their age. Very straightforward. This could also work with the old syntax. I'm going to show you that still works. Get the same functionality, just less typing. All right, and the next one is filtering. Filtering does something cool, like for example, let's say you want to reduce this array and only print out patrons with the age greater than 17. It'll return to you a reduced array where that value is true. So it'll only keep values within the array where this conditional remains true. So in this case, we're going to, first of all, comment this out so we only see the result for 2. Clear the screen, node index. And it's only going to show you patrons that are older than 17, which would be 3 of these elements. There's a whole bunch of use cases you could use filter for. Now you know you have filter in your arsenal for when you want to do that. So the way that works, you pass in a function into the filter function, and for each patron, you return the conditional that you want to compare it to. So you'll have access to the object, then you create some logic that you want to do to get the result that you want. Any questions, at least on filtering? Just to kind of reinforce that point, let's say you want to change only return patrons where the name is equal to, let's do triple equals to Tom. Execute this. You see, it only prints out Tom. Next, we're going to introduce you to map. Map will go through the array, but it's not used for reducing an array. It's used for applying changes to the values within an array. So in this particular example, we have make this bigger. We have a constant called carded movie patrons. The movie patron is mapped, and for each patron, we're going to check to see if first they're older than 17, and then we're going to add a brand new key to them and say can watch rated R equals to true, else can watch rated R equals to false. And it's just going to iterate through each individual object, do this conditional, and apply the change. The difference between map and a filter is that you'll notice in this example, we're returning a Boolean. Map, we're going to return the object itself because the object has to get put back into the array so it doesn't change. So now we're going to execute that. And you see now the object that we started initially has a brand new key called canWatch rated R, and that is either false or true for each of the individual patrons. Questions on filter and map? So let's do a quick exercise where you're playing around with them. That'll be exercise 22.
So it's 31, it's going, each iteration going until 41.
So it iterates through every single object, and then for each object in the array, it does this check. to see if the age is greater than 17, and if it is, it makes an edit to the object itself, which would be the patron, and then it returns that object back to the array.
But it's printing out every single candidate, right?
Yes.
It's not just that. Means it's going until 41 each time. Line 41 each time.
Yeah. So line 41 is going to print out the returned array that this map function returns. So we have this array that's already a constant assigned to this object. Remember, you can't reassign constants, but you can create brand new objects. So this new object being created by calling the map function is being assigned to another constant variable called carded movie patrons, and then that is what's being printed out. Is that cool? All right. Yeah, any other questions on mapping, filtering? Cool. So then in the unsolved, you'll have two files, map and filter, with some different examples that we're going to play around with. I'm going to slack out the instructions for that to give you guys some time to play around with mapping and filtering. This is exercise 22. We will do this for, let's see, what time is it? 10 minutes until 7:52, and then we'll take a 15-minute break. So we'll just extend this all the way out. So if you need to take a break, bathroom break, food break, feel free. And we'll start class back up again at like 8:07. Let's do that. Feel free to work with your classmates if that's easier for you. And just a tip for the map exercise, you'll remember in the previous exercise in the for the map example there, we're returning the patron object back. You don't always have to return the same object in that array. You could return something completely different. If you wanted to return a string here, it would only return whatever string it is that you return back there. So that could be something that people sometimes take advantage of when using maps.
Also, you just press up. Yeah. So the numbers. So the next thing is to go to the original array, go to the array, and then input it's so now you know you kind of know how to filter looks from the list. But then and looks in the certain features passes. Yeah. So filter to the original array and then decide return x from this number goes in here. That's how you start. And you know that because there's so I apply the same method. The first go and second. So yes, fine. Let's break it down. Let's go through so this is going to be
So I feel like that's gonna cause a bit of confusion, but I don't know how to fix it. At least we talked about it. Created right here. As long as it is.
All right. Okay, let's start class again and talk a little bit about the solutions behind this exercise. All right, let's start with filter first. In filter, they're going to give you an example on how it's used, just to kind of refresh your memory. So in this one, they have the original array, which has some numbers in it, and you're pretty much just going to iterate through this array and filter out just the even numbers. So let's console log just that out. Okay, let's go to solved, clear, filter, and you'll see that it only prints out the even numbers in the original array. Pretty straightforward logic behind that, and it returns a true. As I said earlier, filter, you always want to return a Boolean value so it knows which one to keep inside the array. comment that out. The exercise asked us to do the same thing, except we want to now only have prime numbers left inside the array. The solution has a hard to read reference, so I prefer the long form, which was this. I'm going to copy and paste that. So this is just two ways to have to write the exact same, to get to the same conclusion, where we'll take the original array, we'll call the filter function, and then we're going to say for each number in the original array, we're going to pass it into the isPrime function. The solution provides a even more shortcutted way of doing so. I personally think it's hard to read, but you know, everyone has their own opinion. So any questions at least on the very first exercise for filtering? And then for the next one, we want to filter out numbers greater than 5. And so let me console log that array out. More than 5. And then we'll also console log out the prime array. Execute that. Whoops. It's already been declared. That's right. Let me comment this out. And you'll see that it prints out the prime numbers and then also any numbers greater than 5, which is just 10. So yeah. Before we move on to map, any questions on just how that ties together? Feel like you guys are getting the hang of using filters. Seeing a few nodding heads, that's good. That's good feedback. Then for map, let's see. The map is pretty straightforward. They're asking us to triple all the values within the array. They have one where they've doubled it. You're just doing the exact same thing, except you're adding a multiply by 3 to the map. They're using the arrow notation, so you don't even have to include the params or even the function keyword, just shortcuts. In the next exercise, something a little bit more different. They want you to return back even and odd for each of the individual numbers in the original array. So we're expecting what? Odd, odd, even, odd, even. So let's console log that out. Comment these out. Node map. And you'll see that, as I mentioned earlier, you don't have to return the original object of the array. You can return something completely different if that's what you want for your result. They've done this using one line. They're using like a ternary conditional. Just a shortcutted way of doing if conditionals if that's what you want. You could take the more verbose route and break this out into multiple lines. To me, that I prefer that. That's easier to read for me. But I'm an older developer, so people say I'm past my time. So yeah. So any questions on map.js? Cool. Template literals. Let's talk a little bit about some enhancements that you guys have with ES6. This was pretty useful. I like template literals because in this example, we're taking an array, we're taking an object aria that has a whole bunch of objects, and you want to be able to print them out. So you can use a backtick and then access the object directly within the string. So when you print it prints out aria. I'm loyal to House Stark. This is a quick way of being able to access objects. You no longer have to do the very long form of console.log string my name is space plus aria dot first plus yada 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 yada. You can just use backticks, create the string that you want, access the objects directly, speeds things up really quickly. So not too much more to say about template literals. It's just more so that you know that you have an additional tool in your toolbox to use when you're programming. Questions? All right. So you're going to play around with template literals in the next exercise. In exercise 24, print out these instructions. Let's see. In this example, we're going to use ES6 template literals display. First, create a music object following the comments in the solved section, and then use the template literal syntax to display the objects of your data by using backticks. So you can copy and paste this object over here, and then drop that into your constant music so you have a list of objects to play around with. And then you could write your code out using p tags and then display them within the music tag from your HTML. So within your index.html, you'll see that they have a music p tag over here for you guys to insert data into. So as with most things, make sure that you understand what you're supposed to do. In your index.html, they're providing you a p tag with the ID music. In the index.js, they're giving you an element that grabs that p tag, and then you are injecting HTML into the inner HTML, which would be from the song snippet, which they have conveniently provided backticks for you. So you're just going to update this with a whole bunch of other information. So yeah, we'll do this for the next, how much time do we have? Let's do this for the next 10 minutes. Yeah, I'm not sure why they didn't just pre-fill the music object for you, because the most important part of this exercise is really the building out this template literal. So just copy and paste that music object and then build out the song snippet manually yourself. right, so let's talk a little bit about the solution. As you already know, you were provided the music object, which has title, artist, and albums. You just need to update the song snippet with the code to actually reuse those objects within the template literal, and that's going to inject that text into the music element into its inner HTML. So let me save this, refresh. When you load up the HTML initially, it's going to have nothing in it. Of course, if you update the string literal with some text, when you refresh the page, it's going to display that text on the screen. This is just a good sanity check before you even do any of that template literal stuff. Then if you hop into the solution, you will see that they're making it fancy by providing div classes to those elements, and then they're just accessing the object itself using the pound sign and then open brackets. So it didn't have to be this fancy, but you can see what you now have available to you when you are playing around with template literals. You could have just done, kept it simple and just done that, and then you would have had the music title. But typically that's not going to be a use case. You want it. You're most likely going to be injecting HTML so that you can style it up with different classes and all that stuff. And so they just have a fancy example for that in the solution. So any questions at least on this particular exercise? This is just to get you comfortable using template literals. All right. Next, we're going to look at another type of for loop. We're familiar with for each, we're familiar with filtering, and we're familiar with mapping. One of the last for loops we're going to learn about today is just the for loop in itself. This behavior that you see on the screen, for and assigning a constant value of the array songs, and then we're going to print them out, is doing the exact same behavior as a for each. So it's going to iterate through the array and then just print out each of the values within songs. That's all that's happening here. It's just a different format for doing the for each functionality. So you might be wondering, well, if we already have for each, what's the purpose of using this in this use case? Not so much. So the value for really comes in when you want to iterate through maps, because then you can access each individual key and value from a map. So you would have the key bad guy, and then with the value 1, so that when we output this, let me console log this out. Go to my terminal. Whoops, songs has already been declared. Comment that out. You'll see that now you can drop those key and values directly into template literals and kind of speed up, well, not necessarily speed up, but kind of reduce the amount of code that you have to write to be able to print out this entire map. So just know that if you do have a map and you want to iterate through it and access each individual key in a simple way, you do have the for loop available to you to do so. So any questions at least on the usability of for loop? So you could use for each to iterate through each individual array, or you could use a for loop yourself if you wanted to keep things consistent. And actually, one thing to point out, you're going to notice that they're assigning value to constant and not using let, because typically, if you're iterating through an array, you don't want to be able to reassign the reference to that object to something else. You want that to remain constant within your block, so that you can always be sure that whatever it is that you're using it for, whatever logic it is that you're doing within that for loop, remains consistent. So that's why they assign constant to these individual variables that point to objects in the array and the map. Any questions? More tools for the toolbox. So we're going to take a look at another quick exercise, exercise 26, which is just going to reiterate the use case for, and it's going to ask you to select all of the songs in the index.html. So when you look at the index.html, you're going to see a UL tag with the ID songs. It's going to have a whole bunch of li tags inside of it. You guys are going to use the document object that you're already very familiar with, and possibly query selector function to select all of the objects within this HTML tag over here. Once you have all the objects in the back end, then what they're going to ask you to do, add the class that changes the color to red. Yeah, that changes the color to red. So you're going to have to create a CSS file that just assigns red to the text. So you're going to create a CSS file with the class, name it, maybe you'll name the class red, and then just have the object color red assigned to it for these individual objects. So you're just going to make sure that this ends up like this for your CSS to apply on the screen. So let's take 10 minutes to tackle this exercise. Once again, we're going to grab all the objects for this HTML and assign the class to it. You can name it whatever you want, but keep it simple. Let's say it's red, and that's just going to change the text of each of these objects to red. And you're going to iterate through those objects using the for loop syntax that we just learned about in the previous exercise. So yeah, let's take a crack at this for 10 minutes, and then we'll talk about a solution. And I'm going to provide some documentation behind query selector, so you can read this and understand how to use that for this particular exercise. Okay, let's take a look at the solution. So, simplest part, you want to create a CSS file. For some reason in the solution, they use the color green instead of following the instructions and using red. I'm going to change that to red. So I'll refresh the page, and my text is red. Then probably the harder part out of this was just understanding how to write the syntax for document query selector. But documentation I sent out earlier should cover that. If we scroll through this, this is just another exercise of getting familiar with how they document things online and trying to figure out how do I find the answer that I'm looking for out of all the text and jargon that you see on the screen. And I clicked the wrong thing. This is the one I want. Query selector, document query selector. If you scroll through this, blah, 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 it shows you how to get a list of p tags. And then the one that matches what we want is here is a list of p tags that whose immediate parent element is a div with a class highlighted. So you can see that the div highlighted with a space, what's it called? Greater than symbol with a p will take all of the p tags with the parent div highlighted. In this case, we want all the li tags with the parent ui, so that would be the syntax we would use. Once you get all the songs, it's just a matter of iterating through the songs and then adding to the class green. So, any questions on that? So, just more tools to the toolbox. That's what this entire class is all about. The next thing we'll take a look at is a concept called rest and spread. Let me comment all this other stuff out before we confuse ourselves. So, in this very first use case, this is number 27. We have a basic function that adds two arguments, x and y. Instead of passing in only two arguments, JavaScript will allow you to pass in a whole bunch of arguments. It won't create an error, so but it will only do what you would expect it to do, which is taking the very first two arguments and adding them together and returning a result. So in this case, it takes 1 and 2, adds them together, returns 3, which is still technically correct, even though the syntax of using this function is actually wrong. So, what if there is a use case that you wanted to pass in an unlimited number of arguments? Let's say you have no idea how many numbers your users are going to pass in, but you want to provide the opportunity for them to pass in as many arguments as they want. That concept has now been introduced in ES6. It's called rests, the rest of the arguments, so to speak. We redefine add with 3 dots. That's really the key syntax behind defining that you're going to use the rest of the arguments that are passed in. Since we know this is now going to be an array of sorts of arguments, let's actually console log that out so that you can see what that looks like. Nums. Alright, save that. Comment this out. So let's take that very first case where we add 1. Oops. So node index. You'll see that we're now printing out an array with just 1 argument in it. So now that we know that by using this syntax we're going to expect an array, we can now then iterate through the array object of untold number of elements and do whatever it is that we want to do with them. So in this case, we're using the for syntax, but we could easily have also used for each with the exact same result. So for this example, we're going to pass in 4 elements. We're going to loop through all 4 elements, and we're just going to add them together and return the result. Index. As you can see, well, actually, let's console log that out so that we can see the result. No. And you see it's added all the numbers up to give us a total of 11. And we continue to add to this as much as we want with nothing breaking, because we know that array is just going to continue to grow and just going to continue to add all the arguments that I pass in. Does that make sense? All right. Then, let's see. Whoops. You can also use rest for playing around with objects. So let's take a look at this function. So this, now that's just gonna reiterating the fact that you can pass in an untold number of arguments, and it's just gonna print out the length of the array that you're sending in. But it's not a very, we already talked about that. Let's look at something more interesting. It's a concept called spread. So we already know about rest. Rest will turn the rest of the arguments into an array for you to use with whatever logic it is you're trying to do. And then spread is a concept of expanding an array. You're spreading it out. So we have two arrays being defined over here. Let me bring these to the top. So we have a variable called dragons, which has 3 dragons inside of it. And then another variable called weapons, and that has dragon glass. And now we're making a reference to the first array, but we're adding 3 dots in the beginning. What this does is it expands dragons out and combines it into the array that you see over here. So when we print this out, node index.js, you're going to see that dragon glass comes first. The first array gets expanded out, and then you have wildfire at the very end. Just a real quick way of getting you to kind of like combine arrays together. So the old way would have been you have to iterate through the entire first array and then push it into the new array in the order in which you want to get it pushed, and it becomes a lot more complicated. So this just kind of really speeds things up. So rest and spread. Rest of the array, turning all your arguments into an array so you can play around with it within your logic, and then spread, which is spreading an array, expanding it out, and dropping it into other array objects, so on and so forth. So questions of what we've seen so far. Because we're going to do another quick exercise just to cement resting and spreading. Exercise 28. Let's see. In the unsolved, we're going to take they give you a songs list, and you're going to modify. Copy the songs array into another array using spread and console log out what it returns. So just create another array, use the spread notation, and just console log it out to make sure that you understand what's going on, and just kind of a repetition of the previous exercise. And then the second piece to it is modify the add function so that it uses the rest operator to maintain the same functionality. So instead of only passing in 3 arguments, we want to be able to pass in 5 or 10 and so on and so forth. You're going to need to make sure you update that internal logic to be able to handle the array argument that gets passed in instead of those 3 individual arguments. So we will do this for another 10 minutes as well. All right, let's talk about the solution for this particular exercise. For that first one, it's really straightforward. You could probably just get away with, let's see, let's do another constant. I don't know. Song B equals test space dot 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 songs. That should be all we have to do. Let's confirm log song B. Comment this out to make sure that we're doing the right thing. This is exercise 28. Already solved. Alright, node index.js. Now we can see that we're starting off with my first text, which is string, and then we just expand out the rest of the array into the brand new array that we're creating and assigning it to song B. Any questions on that one? That should have been straightforward. Then for the next one, let's see. They're asking us modify the add function so that it uses the rest operator and maintains the same functionality. You should still be able to pass in any number of arguments. Run the code first in your console to see the functionality. All right, so just comment this out. And let's just run that functionality and see what happens. Index.js, it gave me 6. So it looks like it's just adding all the numbers that I pass in. I want to maintain this functionality. So who wants to take a stab at what we need to do to fix this? We know that it's taking the arguments, it's turning them into an array, and then it's calling array.reduce on the elements. We know we want to use the rest operator so we can pass in any number of arguments. So at least that first ask should be straightforward for us to figure out. We don't even need to touch the rest of the functionality just yet. We need to handle the very first ask, which is use the rest operator. What do we do for that? Exactly, we're going to replace the XYZ with dot dot dot, I don't know, data. So now we know we're getting an array of data. Once we're able to confirm that, let's console log that out, data, and ignore the rest. Execute it, and we see that we're getting an array of 1, 2, 3, which is exactly what's going on over here. So, if that's exactly what's going on in this line, then technically, we don't need this line. We can just replace array over here with data, and we should see the same functionality. There you go. And we don't even need to worry about what reduce is doing. But if you have some free time later on at home, go to this link inside this exercise. I'm going to Slack it out in the Slack channel for you guys to go and learn and explore what reduce is actually doing behind the scenes. But that should be it for this particular exercise. Just taking advantage of the fact that we can pass in an untold number of arguments and then execute them for our business logic needs. Questions? All right. And last and finally, the last tool for our toolbox we're going to learn about today is this concept called destructuring. So we have this constant aria, which has a key, name, and parents. Same thing with Jamie, name, and parents. The old way of being able to extract out these individual data pieces from these objects was to either one, we could assign it to a variable and then console log out that variable, or we could just call this directly and it would do the same thing. But with ES6, there's a faster way of doing so. So instead of having to have multiple lines of pulling out each individual key from that object, the shortcut would be just to use constant open brackets and the keys that we want to extract from that object. Once we have that, then we can reuse those variable names to do the exact same thing that we see above. So let me comment out the rest of this stuff so we can focus on just the new concept being introduced over here. So log this out. So if I execute this file, whoops, I'm in the wrong place. This is exercise 29. All right, node index. We'll see that we're able to extract out the name and parents from the object aria above. Let's move this down. And then reuse them in console logging out. We could also then say we only want name to be extracted out of this object. So when I execute this, you'll see that it prints out aria fine, but then of course we don't have access to parents because we didn't extract it out of the object, and we get a big error saying parents is not defined. Questions at least on that? Just quicker ways to do the same stuff we've been doing. You also have the handy ability of being able to rename keys. So when you extract out Jamie, we move this down. So we're extracting out the name key from Jamie, and we're renaming it Jamie's name. There might be use cases for that, just to provide some more context for whoever is reading your code, or even for you when you're developing your code. But you can rename it, and so the new name of the object you can now use later on, and it prints out Jamie Lannister. So I'm gonna execute that, just so that you can see that it prints out Jamie Lannister for the new name that we're providing the key name. Questions on that? I probably never do this just because I would confuse myself if the name changed from the object key, but in case you ever wanted to do that, you know that you can. Let's see, what else? So then in this one, we can also destructure parameters using the same feature. Where are they up to over here? So they have a variable log character, and that character takes an argument. That argument, we're just going to extract out the character name, the character parents, and so on and so forth. So this was the old way of doing this. In the new way of doing so, better log function, we're going to extract out the name and parents from the object. You guys see this shortcutted syntax that they have over here? They have a instead of the one argument parameter. So this would have been character. Over here, they're going to say, we already know we're getting one argument. For that one argument, we're going to immediately extract out the two elements that we care about, which is name and parent, and we're going to console log that out for speed, or speed of typing. So let's execute that so you can see that in action. Let's comment this out because we're already done with this. So when we execute this, you'll see that we have the extracted objects both following the old syntax where we pass in one argument, and then within the console log we're extracting each individual element from that object. In the ES6 syntax, you can shortcut that by defining the open brackets which define the keys you want to extract from that one argument being passed in, and then console logging it out immediately. Any questions, at least on this shortcutted syntax? Once again, we'll do a quick exercise to kind of reinforce what we're seeing over here. That'll be exercise 30. And within this exercise, we're just going to destructure this using the ES6 syntax. This is exercise 30. Exercise 30. Oops. Cancel. All right, and they're going to give us multiple objects. One is Arya, the other one's a John, and you're just going to pretty much follow the style that you saw in the previous exercise and just extract out elements from these objects in the different syntax styles you saw in the previous exercise. So we'll do this for 10 minutes just so you guys can get familiar with it, and then we'll talk about the solution. just a tip for this exercise. You're going to notice that they're going to ask you to destructure an array. We didn't talk about destructuring arrays, but you guys should see this as a trigger to maybe Google for a solution and see what you can find. Same thing for strings. All right, let's talk about the solution. So, for the very first one, it should be it should follow pretty much the exercise that we saw before, where we have an object called aria, and they want us to console log out the first key and the last key, so we can just grab all of the elements from the object and then just console log them out. That's why this is like so. Keep in mind this should also still work if you just ask for the first and the last element. And we're gonna execute this just to confirm. 30 solved ls clear. Oops. Index.js. It's blowing up for other reasons. Let me comment out everything else. Just the stuff we care about. Can't spell clear. And you can see that we're able to extract out the first and last key from aria and just print them out. That's straightforward. So we'll comment this out and look at the second one. The second one, they want us to extract out each of the brothers' names from the brother key within this object. So the way we're doing so is that we're accessing the object John and then the key family, then the key brother, and then extracting out brother 1 and 2 from this object key over here and printing them out. Questions at least on this one? So then they ask us to extract out or destructure this array. And we haven't talked about destructuring arrays, so whenever in doubt, we go straight to Google. We're going to hit our tab and we're going to say, I don't know, JS destructuring arrays. What do we see? The very first link, destructuring assignment, array destructuring by developer Mozilla. And this shows a pretty simple example of how, if we have an array, constant foo, with 1, 2, 3, you can extract out each individual element by providing a key to the index of that array, and then you could just print them all out based on their index and the variable. So once you see an example like that, it's easy to now reduplicate that over here, and so we end up with a solution like so, where for each index in the array we have the name, alias, and allegiance, and we're just console logging them out. Questions on that? Cool. In that same vein, they're asking us to destructure a string. Because we already know that we can destructure an array, whoops, where did I go? Destructure an array by the index of the objects, you can then turn that string of skills into an array. So you can split them by the comma, and that will give you an array to play around with. So let's do that first, just to kind of break it out into steps. Constant skills array. That will give us an array, and then from the skills array, we're going to extract out the individual elements that we care about, alias, gender, family, and spouse. And then we're going to console log this out. Node index. Whoops. What's it crying about? Identity alias has already been declared. Where did I mess up? Let me comment this out. Comment that out. Alright. Do this again. Okay, and you can see that we have now extracted out each of the individual elements for that string by first turning it into an array and doing exactly what we did for exercise 3, and then printing them all out based on the index and their variable that they relate to. Back to Google Foo, this is going to be what you do pretty much 70% of your time as a developer. New things come out all the time. It's hard to keep track. Every time I teach this class, I learn something new. Because, I don't code in JavaScript every day predominantly. I code in a whole bunch of different languages. So documentation is going to be key in understanding how to use certain features. So Developer Mozilla is always a great resource for the academic, documentation. But blogs are great too. I learn a lot from blogs. So this very next one that pops up, Destructuring Assignment by Sarah Chima. let's say we're curious about what other developers are up to and see how she's describing things, because sometimes it's easier to understand easier to understand concepts when someone explaining it in like more layman terms, less academic terms. So you can scroll through this blog real quick, and when I did that earlier, I learned something new that I didn't know you could do, which is skipping items in an array. So I'm going to make this bigger. And in this solution, she has the array hello, I am Sarah, and she just took the first index and used commas to skip the rest, and then took name at the very end and console logged them out. So these are cool things you can do in ES6 that even I didn't know you could do. Question? Yes, because it's going to be based on the index. Then, same thing she's doing, skipping the first one, grabbing other elements by their index. And then, what else? What else did I see that was cool? Using default values. So in this particular example, she's already set one of the variables that she's extracting out to a default of high, and the same thing with name as Sarah. So when you pass in an array, so let's say this is a function that takes in a random array that anybody could pass in. If they don't have more elements than 2 elements, then it'll default name to Sarah, and you can print it out, and that will just work. So you might have a use case for that. It's just cool to know that you have that option of providing default values for objects. And then another cool thing I saw over here was swapping values for destructuring assignments. They're creating 2 variables, a equals 3, variable b equals 6. She's turning that into a flipped array and then extracting it out using the same keys. We can reassign those variable names because it is a var. It's not a constant, so we can reassign this whenever we want, and this console logs them out in the reverse. Reassigns those variables so that they're reversed from what they originally were. So just cool things you might not have been aware of that the official academic documentation might not always talk about. So always check out blogs. People are usually talking about something cool. And I will Slack this out in our channel. But guys, we made it to the end, man. This is a lot of stuff, a lot of tools in your toolbox you learned about today. Definitely go home and review all of the exercises, because you never know when you might see this in somebody else's code and then have to refer back to this older, to your current exercises. So, yeah, enjoy the rest of your evening. Mm-hmm.